Hello everyone! In this video, we're going to talk about the parts of an intraoral digital sensor and the differences between two types of solid-state detectors. CCD, which stands for Charge-Coupled Device, and CMOS, which stands for Complementary Metal Oxide Semiconductor. First, let's look at the general components of a digital sensor. The sensor is protected by a front and back housing that makes it watertight and light-proof. This prevents damage and ensures that only the radiation we want reaches the detector. Inside, we find a scintillator screen, which converts X-rays into visible light. That light passes through a fiber-optic plate, which guides it toward the chip, while also reducing noise and preventing scattered radiation from reaching it directly. The heart of the sensor is the image chip, which can be either CCD or CMOS. Here, the light coming from the scintillator generates electric charges, proportional to the amount of radiation received in each area. Finally, the sensor electronics. These read those charges and send them to the computer. This includes the analog-to-digital converter, which transforms the electrical charges into digital numbers. Each number is then represented as a shade of gray in the final image. Now let's move on to the difference between CCD and CMOS. In CCD sensors, the electrical charges generated in each pixel are transferred in a chain, one after another, until they reach the analog-to-digital converter. This is a very orderly process, but it consumes more energy and requires precise handling. In CMOS sensors, each pixel has its own tiny readout circuit, allowing the information to be processed in parallel. This makes CMOS sensors faster, more energy efficient, and often capable of integrating the analog-to-digital converter into the chip itself. In summary, CCD sensors provide very high-quality images with low noise, but they are more expensive and less energy efficient. CMOS sensors are more affordable, consume less energy, and allow more compact designs. This is, of course, a simplified explanation. For a deeper understanding, I encourage you to check textbooks and scientific articles in dental radiology. That's all for today's topic. If you have any questions, feel free to leave them in the comments. See you in the next video.